The next thing that we're going to look at is correlation. Correlation is a bivariate analysis that measures the strength of association between two variables and the direction of the relationship. In terms of the strength of the relationship, the value of the coefficient, the correlation coefficient, goes between +1 and -1. A value of +1 indicates a perfect degree of association between the two variables. The direction of the relationship is indicated by the sign of the coefficient. A plus sign indicates a positive relationship and a negative sign, a negative relationship. Pearson's correlation is the most widely used correlation statistic. Type of research questions a Pearson correlation can examine are, for example, is there a significant relationship between age as measured in years and height as measured in inches? For the Pearson correlation, both variables should be normally distributed. It's appropriate to use the correlation when the two variables of interest are scored using interval or ratio data. So the next thing we're going to do is we're going to open a file called examanxiety.sav. So as usual, we go to File, Open, Data, and it's opening in the directory where the files are kept. And we can see the file exam anxiety. So we'll open that file and we can see we've got a few variables. We've got participant code, we've got time spent revising, we've got exam performance, we've got exam anxiety, and we've got gender. And we'll just switch over quickly to the data view and we can see the data here. So I'll just tell you a little bit about the file. So a psychologist was interested in the effects of exam stress on exam performance. So she devised a questionnaire to assess anxiety related to exams. The scale produced a measure of anxiety scored out of 100. Anxiety was measured before the exam, and the percentage mark of each student on the exam was used to assess exam performance. So before seeing if these variables are correlated, the first thing that we would do would be to draw a scatter plot of the two variables. Before conducting correlation analysis, it is important to plot the scatter plots to look at the general trend of the data. A scatter plot tells us several things about the data, such as whether there seems to be a relationship between the variables, what kind of relationship there is, and whether there's any cases that are markedly different from others. A case that's different from the general trend is known an outlier, and such cases can severely bias the correlational analysis. So now we look at the output window and we're looking at this new graph over here, which is a scattergram showing the relationship between exam anxiety and performance. And what this shows is the relationship between people's score in exam anxiety and performance. We can see here that most people have high levels of exam anxiety. Exam anxiety is measured from 0 to 100. Most people have scores up at this end, 80 or more. In terms of exam performance, we can see quite a spread of marks going from 100 down to almost 0. And if we look at the relationship, we can see that most people with exam anxiety have, so well, not all, most, some have low scores, but some have high scores. If we look at the very few that have low scores of exam anxiety, they tend to have very high performance. And this is where we need to think about outliers as well, the effect that they have on the data. We can't actually get a straightforward numerical value from the scattergram. That's something that we will do later. Before going on to correlation, I want to consider another variable, which is the time spent revising. So far, we've only looked at the relationship between exam anxiety and exam performance, but what about how much time people spent revising? So let's bring that into the relationship. And this time, what we're going to do is we're going to go back into Chart Builder. So we're going to go Graph, Chart Builder, and we are going to choose this one here, which is called the scatter plot matrix, and that will allow us to look at more than two variables. So we're going to bring that back into here. And we just drag the variables that we're interested in to the bottom. So we want anxiety, we want exams, performance, and we want revise, which is time spent revising. And this time we'll click on OK. All the other options are OK. And we'll see the graph here. Now this obviously looks much more complicated, and you can see just by bringing three variables into the situation, it does become more complicated because they can all affect each other. So let's start. We'll just start by looking at the one that we looked at before, which is in this section here, which was the relationship between exam anxiety and exam performance. And we saw that quite a lot of people with exam anxiety had poor performance, and but some had high performance as well. Well, what about the relationship between time spent revising and exam performance? So here, that's shown in this section here. We've got time spent revising. The more time that you revise going along here, and we can see that there seems to be a relationship as well. The few people who did a lot of revision did get high marks. On the other hand, those who didn't spend a lot of time revising, some did poorly, but some did well. And if we look at the relationship between time spent revising and exam anxiety, we can see that those who spent a lot of time revising tended to have lower anxiety. Those who spent not so much time spent revising tended to have high anxiety. So we can see there's a network of relationships here. And in the next section, what we're going to do is put numerical values to these so we can see what the strength of these relationships are. So the next thing we're going to do is we're going to run a correlation procedure. And for this, we're going to go back to the menu. We're going to do Analyze, Correlate, and it comes up with 4 different options. We're going to choose the bivariate option. And we're going to choose anxiety and exam. We'll put them in there like that. We're going to do Pearson's correlation coefficient because the data are on interval or ratio scales. We're going to do two-sided tests of significance. We're going to flag significant correlations. We'll just have a quick look at the options. Because it's only 2 variables, we don't need to bother about these just now. We'll just add in revise actually as well. So we're going to look at pairs of correlations, and we'll say OK to that. So you'll see this table now in the output. And what we're interested in is the relationship between exam anxiety and exam performance. And we can see here that the correlation is negative 0.441. That means the more exam anxiety, the poorer the exam performance. Remember, a correlation of 1 means that there's a perfect correlation, so we could predict with certainty. We can't predict with certainty here. We'll talk about that a little bit later, but there is a relationship, and that's indicated by the fact that the significance level is less than 0.05. In other words, if a correlation had been 0, it would have been not significant, but is significant. So there is some association between exam anxiety and performance. However, although exam performance goes down as anxiety goes up, we can't conclude that high anxiety causes bad exam performance. because we also know that time spent studying also is related to both exam performance and anxiety. So we later on will need to take that into account. But even if there wasn't, a correlation doesn't tell you the direction of causality. What it does tell us is how much variability of exam performance might be explained by exam anxiety. And if we square that correlation to get r squared, we get 0.194. So if we convert that into percentage, that would be 19.4%. So that means that 80% of the variance in exam performance cannot be explained by exam anxiety. Nearly 20% can. So in the next section, what we'll do is look at ways of taking time spent revising into account. We'll just have a quick look at some of the other correlations and what they mean. So we've already looked at the association between exam anxiety and exam performance. What about the relationship between time spent revising and exam anxiety? We can see that here the correlation is quite high, negative 0.709. So if we square that, we get a value of 50%. So you can see that potentially quite a lot of exam anxiety is attributable to time spent revising. And if we look at the relationship between time spent revising and exam performance, we can see a correlation of 0.397. So there's also a relationship between time spent revising. So they all seem to be related in some way. And the next thing that we're going to do is try to see if we can look at the various contributions of time spent revising and exam anxiety to exam performance. Now we're ready to look at partial correlation. So we're going to go back into the menu, Analyze Correlate. This time, instead of bivariate, we're going to choose partial. I'm going to put these back out and just show you what I've done here. So this is what it would look like if you were doing it for the first time. So the variables that you want to look at are anxiety and exam performance. And I want to control for the amount of time spent revising. I want to look at the options this time, because it's important to click on the zero order correlations. We'll see why. I'm also clicking on exclude cases listwise, which I've talked about before, so I won't go into that again. Let's click on OK and see what happens. So now we get a table that looks like this. So you'll see that the top part of the table is very similar to the previous table that we looked at. It says control variables, none. And we can see exactly the same correlation. The correlation between anxiety and exam performance is 0.441. However, below the line, it shows you time spent revising. So again, we look at the relationship between exam anxiety and performance. And this time is negative 0.247. So it's dropped quite a bit because of the effect of time spent revising on exam anxiety and exam performance. So there is still an association. It's still statistically significant, but it's much weaker. So what we've done here is we've uncovered some complex relationships between anxiety, time spent revising, and exam performance.